And welcome back. And we're on to the 24th of Feb, 5 a day for further maths. Let's have a look at the first question. Okay, so it's a factorise fully question. This could be a GCSE question, but definitely a further maths type question. Now, on the face of it, I can't square root 75. So this looks like it could be tricky. However, what I do know is 48 divides by 4 and 12, divides by 3 and 16, and 3 and 16 are the key numbers I care about, because this one also divides by 3 and 25, which means I can take a 3 out, and that leaves me with 25 minus 16x to the power of 4. Factorise fully, so therefore I also have to factorise this down to 5 minus 4x squared and 5 plus 4x squared. And that is the first question done. One of those that's very easy to miss a few marks on, but good question. Next question. Okay, so obviously we have a 3D trig question. Now the thing about 3D trig questions is you're trying to create the 2D triangle that you need so you can resolve it. Some people are just naturally better in 3D, but as long as you're working out which triangle you're looking at, that's all you need to know. So there's my line D to G. So the angle is going to be the angle that makes the triangle D to G to E. So just for clarity, let's note the angle I need. So then this angle here, which I'm going to call theta, and I'm concerned about this triangle here, which is the triangle E's up here, D's down here, G's over here. I know D to E is 30, but the problem is I don't know anything else. So therefore I'm going to have to use a different triangle, aren't I? Actually, I've drawn that triangle back to front. Let's draw the triangle the other way around so you can see what I'm doing. So therefore I'm going to be concerned about a different triangle, which I need to look at the triangle D to A to G in order to work out the length of D to G. In other words, I can't work out an angle using trigonometry unless I have two different sides. I know that A to G is 9, tells me on the diagram. I know that A to D is 40, because I get that from the diagram. So therefore, using Pythagoras, I know that D to G is equal to the square root of 40 squared plus 9 squared. Now I'm going to hope this is a nice number, but it doesn't matter if it's not. So 40 squared plus 9 squared, square rooted, oh it is equal to 41. Right, so that means I now know that D to G is 41, which is the one that I've just worked out. So actually this question is not bad at all, is it? So therefore theta equals tan minus 1 of opposite 30 over 41, which is equal to approximately, so tan minus 1, 30 over 41, 36.2 degrees. So 36.2 degrees, let's move it back, to 1 decimal place. And that is question done. Next question. And last question. A curve has equation, gives me an equation. A normal to the curve is drawn at the point A. The normal is parallel to the line with the equation. Find the equation, the normal at the point A. Okay. So this is basically just finding the equation of a line, actually. It's not too bad. I thought it might be something to do with finding the area of a triangle or similar. So a curve has an equation, which means that dy dx, so I can use my gradient function to find the gradient, is going to be 8x plus 2. A normal to the curve is drawn at the point A. The normal is parallel to the line with equation. So I can rewrite this one as y equals, it's x over 6. I don't really care about the other bit, but I'll write it anyway. So x over 6 minus 2 over 6. In other words, the gradient of this line, so the normal's parallel to this line, is 1 over 6. Right, so seemingly I've done two things that don't seem to connect. I've got a function for my gradient, and I've got a function whereby it gives me the normal. So in other words, and this is why this question is quite clever, is I know my normal gradient is a sixth, which means my tangential gradient is minus 6, negative reciprocal. I need 8x plus 2 to equal minus 6, which means that 8x equals minus 8, which means that x equals minus 1. I found of my a value, I found the x coordinate is minus 1. Well, the y value is going to be, well, put it back into the y equation. So in other words, let's draw a little box over here. I like to do this because it just keeps it separated. So my y value is going to be 4 times minus 1 squared, which is 4, plus 2 times minus 1, which is minus 2, minus 3, which is going to be equal to minus 1. So I've worked out my a is minus 1, minus 1. Great. Now, remember, what do I need? I want to find out the equation, the normal, at the point A, and I want it in the form y equals mx plus c. I know what my gradient is, because I've worked that out, it's a sixth. I know what my point is, so therefore I can say y equals a sixth x plus c. Using A tells you that minus 1 equals a sixth times minus 1 plus C, which means that C equals, well, I've got minus a sixth and I want minus 6 sixths, so C equals minus 5 over 6, which means the answer to my question, and this is a really good, clever question, I like this question, is going to be a 6x minus 5 over 6. Good question. Actually, really nice mix of questions today. I thought each of those were quite difficult in their own way, but definitely some quite good questions to think about. As ever, do let me know how you've done in the comments. That'd be great. Do like and subscribe, and I'll see you for the next one. Thanks all.